Welcome back to topic 44 for Algebra 2, nth roots, radical expressions, and rational exponents. In part 1, we're going to first define some of these important terms and then also learn how to identify the number of real roots or real solutions of a given number. Starting off with the terminology. So an nth root of a number, let's call this number c, is x. Now, another way that we can rewrite this is the same thing as x to the n equals c. Now, specifically dealing with radical expressions, there's three main terms: a radical symbol, the index, and the radicand. A radical symbol is used to denote an nth root. And we see it represented as this like check mark house. Now with a radical symbol, there are two main parts. There's the index and the radicand. The index is a number that indicates the desired root. In this example below, we have the cube root of 8. The 3 is the index here. It's almost like in the indent of our radical symbol. Now, sometimes we might not see a number as our index. In that case, it is automatically an index of 2. And that's just because if it's an index of 2, that's a square root. And square roots are very common. So if we don't see a number, it's a square root, it's a 2. If we do see a number, then that's relating to a different root. Now the radicand is the value inside of the radical symbol. In our example here, the 8 is the radicand. Moving along to our first example. What are all the real cube roots of 125? So this is asking, well, x equals the cube root, or the third root, of 125. So what to the third power is equal to 125? In other words, x cubed, or x to the third power, should equal 125. So what number times itself again, gets you 125? Well, I know that 5 times 5 times 5, or 5 cubed, is 125. So in this case, x must be 5. Now thinking back to our unit on polynomials, if we look at the highest degree of our polynomial, that's going to tell us how many total solutions that we're going to have. So looking at our example here, x cubed will have 3 total solutions. Now remember, this does not represent just the total number of real solutions, but the overall number of solutions. So this includes both imaginary and real. Specifically, the number of real roots depends on the given degree. So if we have an odd degree, we're going to have an odd number of real roots. It doesn't specify exactly how many real roots, but it kind of narrows it down. So it could be 1, 3, 5, 7, etc., etc. Similarly, for an even degree, that has an even number of real roots. Let's look back at our problem again. We have any other roots to x cubed equals 125. Can we figure any of this out? Well, we know that since it's x cubed, we're going to have a total of 3 solutions, as we said before. And we know specifically that we're going to have an odd number of real roots. So what we're going to do first is we're going to take x cubed equals 125 and set it equal to 0. So in other words, x cubed minus 125 equals 0. Now this is a difference of cubes, so we can factor it. If we remember, if we have something in the format a cubed minus b cubed, we can break this down to be, well, a minus b times a squared plus ab plus b squared. So using the numbers given with this problem, that will leave us with x minus 5, and then our first term will have x squared plus 5x plus 25 equals 0. Now we can use the zero product property to find out the values of x. So we know that x minus 5 is going to equal 0, and x squared plus 5x plus 25 will equal 0. With our first factor, if x minus 5 equals 0, we know that x equals 5. This is one real root. On the other hand, if we have x squared plus 5x plus 25, there's no number that multiplies to get, no two numbers that multiply to get 25 and also add to get 5. So we'd have to use the quadratic formula here. However, that would give us a negative under the radical. So we deal with actually imaginary numbers. So this whole trinomial that we have here, this gives us imaginary roots. Whoops. There we go. But how many imaginary roots specifically? Well, we know we have 3 total solutions, and one of those solutions is a real root. So with process of elimination, we know that we're going to have 2 imaginary roots. Also, if we did plug this into the quadratic formula and we solve for x, we would get 2 values, because remember, imaginary roots come in pairs. So we'll have plus or minus that value. So specifically, the real roots of 125, the real cube roots of 125, is just x equals 5, and then there are 2 imaginary roots. Let's move on to another example. So what are all the real fourth roots of 16? Here, since we have the fourth roots, our index is going to be 4, and our radicand is going to be 16. So in other words, we have x to the 4th equals 16. So we're going to set this expression equal to 0 and factor. This will give us x to the 4th minus 16 equals 0. Now looking at my polynomial, my highest degree is 4. So I'm going to have 4 total roots, and specifically an even number of real roots. Now I can factor this. So x to the 4th minus 16 equals 0. This is actually a difference of squares. I can break this up to be x squared minus 4 times x squared plus 4. But wait, there's more. We also have a difference of squares right here, x squared minus 4. So I can break up this to be x plus 2 x minus 2, and then bring down this x squared plus 4 equals 0. So again, what are my possible values for x? I can use the zero product property. So I know x can equal -2, +2. Those are my two real roots. Now this x squared plus 4. If I set this equal to 0 and solve for x, I get x equals plus or minus 2i. So this is again shows you that imaginary roots or complex numbers, they come in pairs because we have plus or minus. And this also tells us that these are our two imaginary roots. So 4 roots total, imaginary, there we go, with 2 being real roots and 2 being imaginary. That is part 1 for topic 44 for Algebra 2. Thank you for watching.